Hopefully you had a bit of a break with all the Python weird syntax. I know sometimes it's a little bit annoying. I'm sorry. Now we're moving to some slightly harder stuff. However, if you understand all this, understand all the basics, the data types, the variables, the condition, well, the logic, the operators, and then the sequences thing, and methods and functions. That's quite a bit, but you're pretty good. You're pretty good. You're in good shape. After this, it's not too bad because you understand the basics. I don't have to point out, oh, well, this exact, number, it is doing this. So don't worry, it will get better. Let's first talk about some conditionals. Conditionals basically tell the code only run in certain situations. And this is very useful. So say like you have a program, it's greeting the user. You figure out, do I say good morning, good night, or good evening? Well, it's based on the time of day. So if it's the morning time, then you print out some kind of message. If it's evening time, you print out something else. So that's a way to think about conditionals. The way they're going to work is with the booleans we saw earlier. Remember these boolean operators where we can return like a true or false value? So that's how we're going to structure conditionals. We're going to create expressions that result in a Boolean value, that result in either true or false. So here's an example. Let's say I have this function. The function is figuring out, do I have a negative or a positive number? So I take in a number as a parameter here. And if the number is less than 0, that syntax makes sense, right? If, and I have this condition that either returns true or false, then I can, print out, I can return one thing. Elif just means like else if. So else if there is another condition. Don't write out else if though, it won't work. In Python, you have to say elif because Python is hipster. So if like the number was less than 0, you print out it's negative. If it's greater than 0, you print out it's positive. Otherwise, you're just like, you tricked me. So let's try this out. I'm going to call negative or positive. I'm going to call this function. And I'm going to pass in 0. Is 0 less than 0? That is false. So this is going to be like if false. Okay, so no, I'm not going to run. So this part doesn't run. It doesn't return the number as negative. So it's going to go to the elif block. Elif is number greater than 0. Then no, that's not correct. So it's not going to return this. So then it just goes to this else block and says, okay, else, I'm just going to return this thing. Now, if you remember the meme from before, Python, you put in an extra space, it creates an error. So let's say you didn't format this properly. You didn't put an indent in your code. You can see it's all like red now. And if I try and run this, it's gonna give me some errors. So here's an example. I didn't indent my code properly. That means I didn't put the right spaces. And it says indentation error expected in an indented block. So you have to put indents. Indents just means tabs. So don't try and put like spaces, just press the tab key. And that will let you, put some code. It doesn't just have to be one line, however many lines you want. Line here, except let me indent that too. Lien here, that's French by the way. Lien means link. Random trivia, it's now lien here. But you can put in like blocks. And the if and else if and else, you just put in those keywords. If you need to, you put in an expression, except for else. Else just means, okay, whatever else happened, just never mind, just do this thing. So you don't need a Boolean expression here. You don't need some logical expression here. You just have the keyword if you need an expression, and then a colon, and then an indented block. Hopefully that makes sense. Let's do another example. Let's say I have a divine judgment function, and it is judging the value of souls. I pass in a name. If the name is equal to Elon Musk, then we're gonna hail Elon Musk. However, if the name is something else, then we're not even worthy of judgments. We're not even worthy of existing. So let's see what my judgment is. I go to call the divine judgment function. I put in my name. Man, turns out I'm too basic. So that's another example of us using conditionals. One last thing to keep in mind. Sometimes Python is weird. So here's a function called is something weird. You pass in a thing. If the thing exists, then we say yes. If the thing doesn't exist, then we say no. So first, is something here? And we pass in an integer, 1. Now notice 1 isn't like it's not like a true or false expression. It's not like, oh, 1 is greater than 0. However, 1 does exist. 1 does have a value. And in Python, we call this truth value. That's a weird word, truth. Like I'll spell it out for you if that doesn't make sense. Truth value. It's not like, a logical Boolean, but it is truth. It's like, it's not, it isn't that, but it is like that. So be careful. Sometimes Python will convert this to like a Boolean value of false. It can do that sometimes in other languages, like coding languages like C++. Oftentimes it won't be nice to you like that. So you'll have to explicitly convert things. Just like above, we had that error, remember, where we didn't convert, that integer to a string, and it gave us an error. In C++, you're always doing that. Like that is just like happening all day. So sometimes in Python, you can run into issues like that, where the code might not do what you want if you don't understand what's going on behind the scenes. In contrast, let's say I call the function is something here, and I pass in a value of none. Remember, that's just a placeholder value. So does a placeholder exist? No. That's why this block does not run, and we have this thing, say back no. Now, keep in mind, I am getting like a return value from this function, except there is no return value. Like I didn't specify a return statement. We're allowed to do that. We don't always need to return something. And when we don't return something, then the value of return, you see I'm printing it here, the value is just none. Because Python is just like, yeah, you didn't give me a return value. What do you want me to do? So that's a few things about functions. Here's another practical example. So we have an ingredient checker. We send in some ingredients, so a list of ingredients, and then we check, is there a specific ingredient that we want in the list? So I'm going to run the function. You see, it says, okay, if the thing that we want to check is in the ingredients, then we're like, yeah, you got it. Otherwise, get shopping. And notice in Python, here's another keyword that we can use for making Boolean statements, in. That's very useful. Checking if one element is in a list or a group of elements. In other languages, oftentimes you have to like write a thing that I've said now twice, a for loop, to do something like this. And we're going to see what a for loop is right after. But in Python, you can just use this nice word. So you can see why people like Python, even despite of the weird indentation errors. Now let's talk about that thing. What is a for loop? A for loop is just one type of loop. A loop is something that repeats code. So remember conditionals, they only run code in certain situations. Loops repeat code multiple times. So again, we're trying to reuse code. Storage functions are a storage container for code. Conditionals only run code in certain situations. Loops repeat code. So for example, one thing you should know right before we start, there's this function in Python, again, a predefined function. It's called range. It creates something almost like a list. So um, you have a range from 0 to 10, and it's being printed here, and it's being saved to like this variable called almost like a list. And then what I can do is I can convert the range to a list. Now it says the list object is not callable. I think I did, so I did a kerfuffle up there. Remember I said, hey, don't name your variables list. That's something I did in the last video. I named my variable list, and now it's like, oh, you can't use this, you can't use this Python keyword anymore, because yeah, so yeah, that's why kids don't name your variable the green things. Luckily, there is something we can do here. Okay, in Kaggle, you can click this reset button. It's called factory reset. It just restarts the kernel. Kernel just means, the session that you're running, that connection to the computer with its variables saved. So when I click this reset button, it will start up again the machine that is computing all the code. It will delete all the variables I've saved up to this point, including like a dum-dum. I saved the variable to a name that I wasn't supposed to list. And now hopefully now this works. Please. Oh yeah, it worked. So key lesson, okay? If it's in green, don't make your variable name that, okay? Do not name your variables list. And I know some of you are gonna do it. You're gonna have an error, okay? That's what you get. So anyways, or that's what I get, I guess. Anyways, you can see a range is almost like a list. Here's what's going on. You have this range going from 0 up to, but not including 10. And if I convert it to a list, that's what's happening here. So I'm passing in this range, and then I'm wrapping it with like this list function, again, a predefined Python function that takes in a bunch of different things and converts it to a list. And then I'm printing, the output I get. So you can see here, the range goes from 0 to 9, 0 up to, but not including 10. So that's something just to keep in mind, because we're going to use ranges now. Here's an example of a for loop. I'm going to run it. You see what it does. So the for loop has this keyword for loop. That's why it's called for. And the way it works is it loops across some kind of what in Python is called an iterable, but some kind of group. Iterable just means some kind of group. And the syntax is for each value in some kind of group. So for example, for each number in the range, 0, 1, 2, 3, 4, 5, 6, and so on, print the value that I'm getting. I call this value index. I can call it whatever I want. I can call it I, for example, and the code would still work. It's just like a variable that I'm naming. So for each value in the iterable, for each value in the group, then print the variable. And by the way, when you call the print function, there's this thing that you can do, which is you can think of this as like a second argument being passed to the print function, except it's an optional argument. So the reason why we're saying, this end equals thing, it's because like at the end of each index, each thing that we print out, we want to add this thing, this string, which is like a comma and then a space. If I take this out here, you can see, now it's not putting the comma and spaces anymore. It's just putting like a new line on every single print. That's why I put in, so it would be more concise. One thing you should keep in mind, this is called like a keyword argument. So a keyword argument just means like a argument you pass into a function where you say, again, here's the key and here is the value. So you both say, you don't just put in like the value, which is, what we often do with these functions. We're just putting in a range, that's the variable. It's being passed in as a value to the print and the list command. Instead here, we're saying here's the key and here's the value. The reason why we're specifying the key is because there's many, optional arguments that we might pass in. So Python just wants to know, oh, which of the optional arguments you passed in. Anyways, I hope this is making sense. So for value in some kind of group, repeat some code on the inside. Again, indent the block or else, and put in the semicolon or else. Here's another example. So it doesn't need to just be, range objects, any kind of iterable, any kind of group. So for presidents in presidents, so for president in presidents, again, I could name this like P if I wanted to, but I just called it president. So for each value in this list, you can print the president. And actually, I could, again, any type of iterable, any type of object that is a group. So for every single character in presidents at the 0th element, so Theodore Roosevelt, you can see I'm printing Theodore, like each letter, and then Roosevelt, because now that's the value in every one of these iterables. Hopefully that's making sense. I'll give a quick example of something you might actually want to do. Oh, actually, so here's like, a quick example. So you can have a list and you want to go through all the elements in the list. That is an example of something you might do with a for loop. Very common to go through every single element in an iterable in, a list, a string, whatever. We also have this another kind of loop called a while loop. A while loop, there's a function that uses a while loop. So let's say I want to upload my guy, Elon. I want to give him 1,000 claps. So I send in the name and I send in the amount of claps I need. A while loop, the way that it works is it runs not for, a certain number of values in an iterable. It just runs while a condition is true. So here, the condition that I want is I want to give Elon a bunch of claps. I want to upload my guy. All right. So let's say the amount of claps I've currently given him is 0 until the amount of claps I give him gets to 1,000, gets to the number of claps my guy needs, then we're going to keep repeating the code. What is the code being repeated? This is the code being repeated. So first, we ask the user to input some claps. This is another Python function, a pre-built Python function that says, you pass in a statement, I'll send it to the user and get them to give you an input. And then it takes, the current amount of claps and then adds it, adds the new claps that were given by the user to the current claps. Here's an example of the function running. You might like it. So it says give Elon more claps because, I passed in the name Elon and he needs 1,000 claps. Currently he has 0. All right, let's try giving him 5 claps. Is that enough? No, my guy needs more claps. Okay, let's try 50 claps. Is that enough? No, my guy needs more claps to 500 claps. Come on, is that enough? Oh my gosh, Elon, wow. He just needs a lot of claps today. All right, let's give him 50,000 claps. And you can see this print happened. Your tribute is adequate. All right, Elon got enough claps. We applauded my guy. The reason that worked is because this code inside was being repeated, where we got some input, we got a number of claps, and we kept on adding it to the current number of claps. We kept doing that again and again until the condition was satisfied that the current number of claps we have, that is less than, that becomes greater than the number of claps we need. So while it is less than the claps that we need, then the code keeps repeating. When it becomes greater than or equal to the claps we need, then it stops repeating. And then you again, get out of the indent block, make sure you indent. Indent tells Python, run this code. This is the code to repeat. After you're done the repeating code, then you can just, print the last thing, and it says your tribute is adequate. Hopefully that's making sense. I know I'm talking fast, but this will be out there as a recording for you to review. And you know what? We just uploaded my guys, so we just uploaded Elon, so we're good. Now, the second complicated thing. Okay, this is where things get very ominous. Again, this is about reusing code, okay? So for loops, repeat the same code, functions store the same code, and then finally, conditionals run the same code in certain situations. Now we have something called classes. Classes reuse code again. However, they do this by creating a template, an example of some code, and then allowing copies of that code to be made. So I'll give you an example. Let's say you have a class. So class, that's what we're studying, classes. You define it. Remember with the function, you use the def keyword, def for define. With classes, you use the class keyword, you give it a name. You don't have like any, inputs to a class. And classes can, store some common data. Maybe every single class, it has 4 limbs. So this is an attribute. I know, weird word, lots of weird words. Keywords, classes, that's the template. Limbs, that's an attribute of the class. That's an attribute of the template. And every single copy you make of that class will get this attribute. Those copies are called instances. Here's an example. So let's say I make this class human. I can create 2 copies, 2 instances of this class. So me, Madhav, and Elon, we are both humans. If I print the type of the class, that's another pre-built Python function type. It returns the type of a variable, what is the data type. You can see here it says class, and then the name of the class is human. And down here, what I'm doing is I'm saying, okay, Madhav has, and then Madhav.limbs. I'm accessing this limbs attribute from the class. It got sent to the copy. This attribute got sent from the main template to the copy. It got sent from the class to the child. And we're saying, Madhav has 4 limbs. And Elon also has 4 limbs. So each child, you see, these are child classes. These are, sorry, not child classes. These are instances. These are copies of this template. So it copied over limbs, this attribute to Madhav and Elon, these values, without me needing to say, okay, Madhav.limbs equals 4. I never needed to set this attribute. It just got copied over from the parent class. Hopefully that makes sense. That's one example. How can we reuse the code so that we're just copying over the code from the parent class? Here's another example. So class human2. Not only do we have, this attribute limbs, we also have a method. Remember, a method is just a function belonging to a certain piece of data. The way we define a method is we use, again, the function definition, function name. We also have to write this keyword self. Self just refers to, what is the thing that owns this method. So, for example, if I have a human class and I make a copy, Madhav, the class doesn't know ahead of time that I'm going to call this variable Madhav and I'm going to call this variable Elon. So when the copy gets made, when I call the class like this, then self, think of it as being replaced by Madhav. So Madhav.credibility is equal to some level. Just like I would type out here, Madhav.credibility is equal to some level. But I don't need to do that because I have a class. So again, keep in mind, it's copying some code. This is the template and the code is being copied over to each of these examples. So let's say over here, I am Madhav, human2. I set my credibility. I have 0 credibility. I have no credibility. My credibility is none. And Elon's credibility is level 9000. So here I'm printing out, my credibility, none. Elon's credibility, level 9000. I hope this is making sense. We have these methods where you have the attributes and the methods of the parent class. It automatically gets distributed to the child classes so that I don't have to define, what does this method do? I already defined it when I define the class. Hopefully this is making sense. By the way, just something to note, we just created our own data type. That's what we're doing with classes. Look, I have like this list. I created a list. If I print the type of Madhav, this class I just created, and the type of list, you see how they both say class? It's because at an underlying level, a lot of things in Python are classes. in machine learning, we're going to be working with some tools later on that are just, composed of different classes. So everything in Python, the reason why we can call, my list dot append is because Python already predefined a class that is list and a method for a class, just like we defined a method for our class up here. So it's like we're just creating our own data type. I hope you think that's cool. I thought that was really cool when I first realized that. One last example, then we're done, I promise. So let's say we have a class, human, human3, you have this attribute, and you have our method. So in this case, we have, a different method. Up here we had set credibility, that's one method. Up here we have a different method. In classes, there is like a special method called underscore underscore init underscore underscore. That's a weird name, but it's again one of these names that is reserved in Python. Just like, I can't set list is equal to some variable because that variable name is reserved. This method name underscore underscore init underscore underscore is reserved by Python. Python runs this method whenever we initialize, that means create, an instance, that means, a copy. So when I say Madhav is equal to like human2, this is when I'm creating this instance, whereas this is when I'm initializing it. Python runs this method automatically. And here you can see what I'm doing is, again, I have self to refer to, I don't know if it's Madhav or Elon, it'll get filled in later on, but I pass in a few, a few variables for our class. So here I'm just checking, if there is a name, if that thing exists, if it has been passed in, then self.name equals name, self.age, and so on. So I'm setting these classes when I have the class being initialized. And you see here, now I'm actually passing in, a name, then an age, then a credibility. So before I could just initialize an instance of the class. Oh my gosh, so many big words, but I could just create a copy of a class without passing in any variables. That was because I hadn't defined, a custom init function, which is just me hijacking Python's reserved words and saying, oh, by the way, Python, please, run this code when you initialize the class. So I have this method, get income. And now, once I've initialized the class and I have these variables, I have these variables passed in, then I can reference them again. That's why we have this self method, this self method in, this self keyword in these methods, so that later on I can go and access all of these different attributes. Self.age I set up here, self.credibility I set up here, and so on and so on. But anyways, this is a weird way of me, again, making fun of myself. I have this method I created, get income. In the class, remember, I'm not defining it for myself, Madhav, and then Elon. I'm just doing it once. And then I get my income, it's 0. If I get Elon's income, it's 4.5 billion per year, which is probably an underestimate. So there we go. Hopefully you're starting to get a sense of how classes, they're templates. We make instances of classes. Those are copies. And the things that they copy are the attributes that any class can access. The things that they copy are the methods. Sometimes there are own methods here. Sometimes there are reserved methods in Python that we just hijack to do what we want. Hopefully this is making sense. And with that being said, here's just one last thing to keep in mind. We can actually nest classes within classes. So we can copy, this code and code from another class. This is something called inheritance. It's kind of weird, but here's an example. So when we nest a class within a class, let's say I create a class entrepreneur. It is a child class of the class human, because an entrepreneur is a human. So this is the syntax we do. in parentheses, we put, the parent class we want. Up here, we had no parentheses because this was, just a class. There was no parent class. And here we can put all the new code we want. So we can create a new init function. Just one thing to keep in mind, we have to do this thing called super and then init. The reason is because when we create an init function here, an init method, I should be saying, and an init method in the parent class, then Python doesn't know, which one are we calling? What? So what we have to do is, one init method for the entrepreneur child class. That's where, here we have an entrepreneur. We pass in some information, we pass in some arguments here, name, age, credibility, net worth. And then in the init function of the child class, we're just setting the net worth to, whatever we passed in. However, we're also calling this thing called super. Think of super just like as in human3, because that is the parent class. Think of this as human3, and then, calling the init method, just like we call other methods like get income, we can call this init method. Think of it like that. And what it does is it says, okay, I'm creating a new class, entrepreneur. When someone creates an instance of this class, someone creates a copy of this template, go here, run this init function, and then when we're running that init function, also run the init function of the parent class. And here it'll run the code, it got passed in the name, age, and credibility. You can see it got passed in the name, age, and credibility. It'll say, self.name, self.age, self.credibility. So this one line lets us reuse all of this code. And then, it also does whatever it wants to do in the child class. So for example, one sec, before I get to this net worth thing. So for example here, entrepreneur, I'm creating an entrepreneur class. I pass in these variables. It goes to the init function because, I just created a copy of the template. And it sees first thing, okay, go to the parent class, which is human. We specified it here. And, do all this in the parent init function. And once you're done all that, and you've set all of these variables, Elon dot net worth, Elon dot name, Elon dot age, and so on, then go on and set, another attributes here, the net worth, which I passed in. I know this is confusing. I'll link a resource here if this seems too fast, but the general idea is we're copying a bunch of code. So we're reusing the code again and again. One thing here, you see, here it says human3 object has no attribute net worth. That's because Madhav, and you see, by the way, in these errors, it tells you which line of code is wrong. So that's useful. It says there's something wrong here. The reason is Madhav is a human3 object. It's a copy of this template. Entrepreneur is a copy of this template. Elon is a copy of this template. And Elon has a net worth. I do not. I have zero net worth. This is just a lesson on self-deprecating humor, but if I delete this line, there we go, we got Elon's net worth, and I have none. So that is basically the end of the lesson. By the way, super, it means super, because just like superscript, super, top of a word, that's kind of like, you have this parent class, and then underneath it is a child class. So human3 is the parent class, that's the child class, entrepreneur. Hopefully that makes some sense. And last few tips. Do I even want to do this? You know what? No, I'm not. So I have a few tips here. I'll leave a link to this notebook. You can actually go on Kaggle, share your notebooks, and there will be a few cool kid tips, if you're interested in doing things a little bit more efficiently, a little bit smartly. Whatever, I'll include it. So one thing, hey, this looks weird. You have to do a bunch of typing, concatenate some strings. Make sure, if this one is, an integer, then you convert it, to a string. Madhav has 4 limbs. If you don't want to do that, there's this thing called an f string, which is like format string. You just put an f, then quotation marks, then you can type in whatever string you want, and then put in like variables in square brackets. And it'll automatically convert all of this. So it saves a bunch of space, less typing. Another thing, sometimes like you're defining really complicated functions, like look at all this business. This is just something to take the dot product of two vectors, all of this stuff. So you see, vector 1, 1, 1, 5, 5, 5, if you've looked at the matrix operation lessons, 1 times 5 plus 1 times 5 plus 1 times 5, that's 15. Sometimes we don't want to do that. Sometimes we just want to, use code quickly. That's when we have modules. Modules are like bits of code that people have already written for us. We can import the modules, import some name. Typically, we'd have to install this module, NumPy. It's a module for doing things like dot products. However, in Kaggle land, they already set it up all for us, so it's really convenient. We can just put import. This is just like renaming the module, so it's, quicker for us to reference. And if I print the type of this module, you can see it's just another class. Who would have expected? And then np, numpy, it already has this dot product function for us. It's a method of this class, just like all these methods we defined up here. And this method, np dot, you just put in the same things, these arrays, and it'll do it for us without all of this random stuff. So there you go. That is cool kid stuff. That is a huge lesson. I'm sorry, I know it was long. However, I will make sure to record this. I will make sure to give you links if you need to review anything. And I really do hope that if you review some of this stuff, especially classes in inheritance, then it will help you better understand the foundations of what we do moving forward. So I'll stop this recording here. We do have